sets as well, just in case you want to actually run the data sets. I'm not sure how many of you have used R, so I will, just be very pedantic and say, okay, let's go back and look at how to actually upload certain files, just because obviously you can't run R scripts without having your actual file, your data set in the same folder as your file, basically. So that's something I'll just reiterate, just in case anyone's not quite familiar with R or hasn't used it too much, because that's sometimes a frustration for people. But yeah, like it can be avoided by just pointing that out. Okay. So I will say, interestingly enough, when I started this presentation, I somehow forgot that Tidyverse is a collection of packages. So, and in fact, if you look and see, you'll see there's a lot of packages, some of which we all use, or some of which you'll find yourself using quite a lot in data science and data visualization, like things like ggplot, readr, because obviously when you want to read the data set in, you're using readr, things like, Tibble, things like, dplyr, tidyr, you'll find yourself using a lot. And then there are things like purrr or string r, which I sometimes use, but not always. So because it's an introduction talk, I kind of focus on the big ones, which we always tend to use. And I left a link here that says, here are the other packages, or here's information for the packages. So if you're curious about how the other ones work, you can feel free to play around in that site. This is obviously designed by Hadley Wickham. He's on Twitter. So I think he developed this in the early 2000s, like maybe 2005, which I came into knowing myself maybe about 10 years later. Yeah, so when you want to install packages in R, you use install.packages. So if anyone has not actually installed Tidyverse, you can by just taking, this line of code I put here and just applying it to any part of R. So you can put in the console here and run it. Or, if you are using R Markdown, which I do actually use in that file I posted, you put it in the R chunks here, right? So I already have Tidyverse, so that means I'm going to run the library because it's external, right? So I want to actually load the library. So this is an external package that I'm going to run. I will point out that I already have my script in the same folder as my data, but in case you guys have not done this before, you have to set the path, right? So because it's entirely possible that your file is not in the same folder as your actual script, in which case when you try to load your script, it won't run. So I just, to source file location, you'll get a function that says set working directory, which will tell you exactly where your actual, your script happens to be. So you just want to make sure your actual folder, your data is in the same folder. So this is my working directory, which means that wherever my data happens to be, it should be in this folder, basically. I'm just going to point that out. Yeah, okay, so cool. So I actually started by using something that's actually in the global environment because I didn't want to, run too many, I didn't want to have too many external data, sources, but mtcars is actually a data set that everyone uses. In fact, if you just type in ggplot2 into Google, you'll actually see they use this example quite a bit. So it seemed natural that I pulled it up. It's actually inside the global environment of R. It's within base R, right? So I will say that Tidyverse is almost like an intermediate thing you use after you've seen base R, right? So, and I was thinking to myself, well, making this workshop, why exactly is it important, right, to use Tidyverse? And I realized the reason why Tidyverse is quite handy is because base R sometimes is not. And to really understand why you would use Tidyverse and why when you have base R manipulations is to see how base R compares in some situations to Tidyverse, right? So Tidyverse efficiency is in some sense seen by the inefficiency of base R. So I'm going to, in some circumstances, show you how it looks in base R to see why I would prefer Tidyverse. And sometimes it's cosmetics too, like ggplot has really excellent plots and base R does not. So when you're thinking about publishable plots, people tend to use like Tidyverse ggplot just because it looks sophisticated, whereas the base R plots don't necessarily look sophisticated, no matter how much you manipulate the actual plots. Okay. So this is within, the global environment of R. It is a 1974 data set, and if anyone knows what that, what that insinuates is that obviously when you have a very old data set, you have sparse data, right? So this is actually a data set of only 32 observations, because it's not. We have this data boom now in the 2000s, but obviously in 1974 data was sparse. So there's only 32 observations. It's looking at like things that might influence fuel consumption in different designs of motorcycles from 1973 to 74. So if I, load this, I'm just going to say it's, I just called it cars. Just with a caveat, if I want to use my variables within R without having to actually do something like this, like cars $, like the MPG. To avoid doing this, I have to attach my variables. This is why I attach cars, because if I don't, what will happen is it'll have to always call the variable from the actual data set, and I don't like this. It's clunky. Okay, so I'm going to run it. You can see that all the variables are now loaded into my global environment. In fact, if I have a look here, you can see that they're all there, right? So this is the global environment, which consists of, again, 32 observations and only 11 variables. It's not a very big data set, but that makes sense. It's 1974. So yeah, these are the features of the cars, right? So you have MPG, CYL is cylinder, like how many cylinders the car has. And anyways, just to, if you want to know how the variables are actually working, one thing you might want to do is go to help of, MT cars. I always have a look here and it tells you what each variable is actually, referring to. So this is obviously, like I said, it's a data set from 1973. You can see that the variable labels are here. So number of cylinders, miles per gallon, displacement, these are all like the things weight per 1,000. So when it says something like 3.4, it's really 3,432, obviously, pounds, but scaled backwards just for, to have an inflated model. But yeah, so I digress. This is the data I'm working with. So here's the data, I just put it here. The first package I'm going to talk about is probably my favorite, just why I started with it, is ggplot2. It's really the data visualization package that's inside of Tidyverse. So if you actually load Tidyverse, I should have pointed out, you will actually see that it does give you the packages that are inside there. You can see that ggplot is there, Tibble, tidyr, readr, cur, dfire, string r, and forecast. And these are all the packages, which means that because it's a collection of packages, technically speaking, you could actually download each of these packages separately. So I could have did something like install, packages, and something like ggplot2, but you recognize that this package is already inside of Tidyverse. So once you install Tidyverse, you get all these collection of packages, right? So I'm going to focus on the ones that are most common. That's these ones here, and then dfire, right? So my favorite is ggplot2 because when I started statistics, I was using base R, and I realized that base R lacks sophistication when I was making plots. I was a third-year undergraduate student, I believe, when I started using base R, not Tidyverse. Tidyverse I started using a couple years after. But the plots I was making in base R was clunky and lacked sophistication and not publishable. And I realized at that point that I was considering graduate studies in statistics. So I was looking for a way in which I could obviously publish my findings. And so obviously the nature of how I actually presented my data kind of mattered to me. And let's suppose I wanted to understand the relationship between weight and miles per gallon. So these are variables that are inside the cars package, right? So if I want to understand the relationship between weight and miles per gallon, you might think, for instance, that the heavier your car happens to be, right? And of course, the more you're going to guzzle gas, basically, right? Or the slower your car will go. So maybe your miles is going to be, like in some sense, mitigated by, I don't know, like I'm not very good with cars, how heavy your car happens to be, right? So just want to check and see miles per gallon happens to correspond to, so how much does your car actually, how much did your car actually move before when you're guzzling gas, basically, right? So how many miles did you actually go per gallon? Obviously, in some sense, it makes sense. It's related to how heavy your car happens to be. So I just want to point out that whenever you have a working framework as to what your X and Y variable happens to correspond to, right, you're going to obviously plot this on a coordinate system, right? So that's what I'm doing here. When you use ggplot, you will actually see that to actually increase features on your actual plot is to keep adding to it. Like literally, you see when I just do the bare minimum, I feed ggplot a data frame, right, which is cars. I give it a coordinate system, which is just X is equal to weight. And I think that MPG is a function of weight. So, Y is MPG. I haven't asked it to do anything. All I've done is plot the coordinate system. Right? Oh, great. Thank you, Claude. All I've done was actually plot the coordinate system. I have not actually asked ggplot to do anything for me. Right? So you can see that That is why what you see is literally the coordinate system that corresponds to the summary statistics of like the weight. So the lowest value weight can take to the highest value, and the same thing with MPG. So if I, for instance, go and look at the summary, weight, you can see that the minimum is 1.5, the maximum is 5. That's why you see the plot look like this. Similarly, so the summary of MPG, you'll see that its minimum is 10, the maximum is about 34. This is why, it ranges from like, let's say 10 to 35. It's giving a coordinate system, but I haven't asked it to do anything. Now, we know that if we want to look at the relation between two variables that are continuous, their instinct is actually the scatter plot, basically. So if I, want to add features to my plot, of course, what I'm going to do is I'm going to tell the ggplot to do it, basically, right? So if I just run this thing here, which is just the bare minimum. So if I just take the code here and I just put it into ggplot, all I'm going to get is just the coordinate system. You can kind of see, right? It didn't do anything. Now I want to add features. I want to look at the relationship between these two continuous variables. So I'm going to add features. The first thing I'm going to add is color, right? So I might think that perhaps there could be some kind of, there could be some kind of pattern, right? Maybe cars that are heavier have a different MPG than cars that are not. This is why I might actually add a factor of cylinder. So recall from the actual help section, cylinder is number of cylinders, right? So there are 3 cylinders. If I just look at if I just view the car data set again, you'll see that there's actually 3 levels, 4, 6, and 8. So it's a factor, right? But it's a factor that is discrete. But these variables look discrete. So if I don't actually factor them, you will assume it's a continuous thing and give me a color gradient that's actually continuous. So I recognize that this is discrete levels. I need to ensure that my variable recognizes it as discrete. So I put as.factor CYL to show, right, that it's not a continuous scale, it's a discrete scale. And I want to color coordinate to see if there's any kind of relationship between, weight and, MPG. So if I just run this, which is me adding, so I've added a feature here, where I've added the factor of the cylinder, because I think that maybe this relationship is mitigated by how many cylinders a car has, basically, right? I still only get the same coordinate system because I haven't done anything yet. I have to add features. So whenever you want to add features, you add plus the feature itself. So when I say plus geom point, I am asking for a scatter plot between 2 continuous variables, right? So if I just run this, right? You'll see, I'm gonna just, sorry, 1 second. Oops. Sorry. I don't want to run the whole thing, but maybe I'll just run it and I'll explain it step by step. You'll see that I will get, where is it? No, not this. I want you to run this. Sorry, 1 second. I'm having logistical issues with my plot. Sorry. Oh yeah, I'll get this basically, right? So let's think about what I've just done here. And this actually picture you see this graph I'll show in a second. What have I actually done here? Well, I factored to recognize that there's actually 3 levels, just 4, 6, and 8. But you can actually see that because I've said color, which is the color based on the type of actual cylinder you're working with, basically, right? It recognizes that 4 has a different MPG than, let's say, 6, which has a different MPG than 8. And this is reflected in the plot base, because you can see that it's actually partitions my data into 3 different sections, depending on the cylinder you're working with. And so I actually added this geom point, sorry, I added geom point, which added the actual points. But if I don't add the scale color, it will actually just give you black scatter plot. So if I just do this, if I just run this, you can see that, oh, sorry. I want to see if there's any way I can just, actually, once I actually add color, it just gives me, if I remove, so once I actually add color, it just gives me 3 colors. But if I remove this, you can try it yourself and see if any of you have your actual R code open. if I remove the as dot factor CYL, what it will actually do is give me just a black series of dots. So it won't actually color coordinate based on the actual cylinder, right? So if I just remove this thing here, if I just remove this for a second, and just run it, it should just give me a black scatter plot, right? So, oh, sorry, there's something wrong with my code. It's another thing to learn to recognize that it's very picky. It can be very finicky. So it doesn't like when you, yeah, it can be very finicky as well. Sorry. What I want to do is remove, okay, maybe you have to take my word for it because obviously I'm having a bit of technical issues, but yeah, if you just remove this, if you remove the color here, try yourself later on, but I won't because obviously it's giving me a hell of a time right now. Let me just try one more time. You will remove the actual color from your plot basically. Yeah, there you go. You can see you just get the series of black dots. So even though I've given it a color scale, even though I said scale underscore color underscore manual, and I've given the values that I want, which by the way, you could change. If you don't want, like gray, blue, and yellow, you could change the colors yourself and it will give you the colors, maybe green, red, and blue, whatever colors you're looking for, you just change this color scale here and then we'll give you different colors. But even if I actually ask for a scale color manual, it won't actually give me a color until I factor. So you have to give it a variable that you think is discrete and to tell it how you want it to actually color, right? So keep in mind that this gradient system is only for discrete things. When you say as dot factor and color equals, you have to give it a discrete variable. If you give it a continuous variable with too many levels, it won't run. You'll run into complications, right? So that this is really a thing you do when you're mitigating variable, which you think is influencing the relationship between two continuous variables, is discrete, right? So just keep this in mind. But you can see that if I wanted to make a similar plot in base R, so I'm gonna give you a similar plot in base R where I've actually looked at MPG as a function of cylinder. You will see how it looks in base R versus ggplot, and it's not that it doesn't work in base R, it just doesn't look as nice. So if I want to look at the box plot of, let's say, MPG as a function of how many cylinders a particular car has, right? So I'm going to say, MPG, which is on the y-axis, is a function of cylinder, and you're going to see that I'm going to look at this relationship or explore it, for 4, 6, and 8. So if I run this, I get the following plot, which isn't bad, and I can keep adding features. I could change the label of the x-axis. I can change the label of the y-axis and make it look prettier, but it's still missing something, right? So it's not terrible, and I've definitely seen papers published with plots that look like this, but you can see that when I load a similar comparable plot in ggplot, it just looks better, right? So a similar feature in ggplot would be, you feed a database, which is cars, right? You factor based on obviously the variable that you're interested in, which is CYL. So it is both, in this case, it's both the actual X variable and it's also the color, it's also the thing you want to color. So because it is itself discrete, it's both the actual X variable as well as the color, the variable you want to color on. And so when now instead of putting G on point, because I'm looking for a box plot, I put G on box plot. So similarly, if I wanted to look at a histogram of something that's continuous, I put G on hist, right? So you can see that if I run this, it just looks tidier, is the name of the package implies, right? So I could obviously remove features. So if I was going to publish such a graph, I would probably remove the background grid, and you can do that. You can obviously explore things like grid panel, which will, and when you want to add grid panel, you just say something, plus grid. I think it's dot panel, right? So you keep adding things to remove the background, right? So, or maybe it's actually theme. Let me see. Yeah, you would change, you put theme, maybe you want theme black and white, theme gray. So you just keep adding to your plot to remove features. So if you don't want to publish, because no one published a paper where they have this gray background. So when you wanted to remove certain things and you wanted a black and white background, you would just keep adding things to your plot, but you can see that it looks tighter, even without actually making it publishable level. It looks a lot tighter than the actual base R plot, right? So and you can keep doing these things if you want to just look at characteristics of just one variable, for instance. then you still feed it the same data set, but instead of giving a coordinate system based on 2 variables, you give it based on 1. So if I just, for instance, run this part here, and I want to look at the histogram of weight, then you can see that I'm going to get a coordinate system with just with the 1 variable here, which is weight. And when I want to add features, I'll just say plus the thing I want to add, which is geomhist. Now, this is pedantic, but I put bins equals 5 because the data is sparse. And when you don't specify bins, it's less than, let's say, 10, you'll get a bunch of sparsity in your histograms, right? So to remove the sparsity, right? And you can actually see when I don't do that, and I just run it like this, you get all these sparsities in your data. So that doesn't look, sometimes it actually hides the shape of the distribution when you have all this sparsity in your data. So to remove this right, to undo this, I kind of just simplify the bins, but you can see that I actually added features. So I said, I want the color to be black. So the black is the actual shading along the actual rectangles, and then the fill itself is the red. So you could say, color equals, let's say, gray. And instead of having a black border here, you'll have a gray one. You could say fill equals yellow, and it will just change the features of your histogram. But you can see that it's very easy and tidy to actually add and subtract these features from your actual variable in a way that it's not when you're, so if I wanted, for instance, to change X, I would be able to say something like, weight. And it would just kind of, change it for me. So this is something that is, when you do these kind of things in base R, it starts to look clunky. So you keep adding to the, to the right in Tidyverse, almost like an SQL sequence. Whereas with base R, you keep adding lines and lines and lines of code to the point where it looks clunky. So this is why I tend to prefer Tidyverse. It's just things that just look tidy and efficient. Yeah, so that's kind of ggplot. And I guess I'll move to read R. This is probably the least interesting part of Tidyverse for me personally. But I'm going to still explain it because we do it without thinking about it, right? So read R is just a way in which we actually read our rectangular data into R. So rectangular data mean like, each column is a variable, each row is a case. So it's literally a rectangle. You have a rectangle of variables along the column space. And along the row space, you have like just the observations for each person. You read it into R in a tidy way. Now, the reason why I think this is the least interesting is because obviously you have these functions both in tidy R and in base R. And sometimes I ask myself, well, what's the point, right? So why do we care to read it in using Tidyverse instead of base R? And I guess for the most part, we wouldn't really think about it, right? So because most of us are really doing our data manipulations outside of R, so when we actually look at R, we're dealing with the clean data. A lot of us don't do the back end stuff. We're seeing the clean data. And because we see the clean data, we don't think about how fast we load our data into the console, right? So I will say that when read R is a way to read it in. So you have read underscore CSV, which reads in CSV files. And because the data I gave you guys is actually the CSV files, we'll be using this, right? Obviously, right? This is working similar to read.csv in base R, which also reads in CSV files. We also have read underscore table, which reads in like text files, like tabular data, right, where you have white space. So those are like, if you save the data in Notepad or something, you would read underscore table, which works similarly to base R with read.table. So you might say, well, why do you care then? Like, isn't it, what's the point, right? You have these functions in base R. I will say that it depends, right? So it is true that the functions exist in base R, but in fact, read underscore CSV actually imports the data as a tibble, while read.csv imports it into R as a data frame, right? So you might say, why does that matter? In the past, it actually didn't matter, right? So in the past, it mattered because it turns out the tables load faster. So this matters when you have very voluminous, you have a very large data sets. Tables actually load faster than data frames. They also don't create row names, right? So when you don't specify row name in base R, it actually starts creating variable names for you, like V1, V2, V3, etc., which isn't a big deal, but really the bigger issue is actually it allows for non-standard variable names. So base R doesn't like when you give variable labels that have numerical values in it, whereas Tibble actually allows you to do so. So if you don't feel compelled to change the label of your variables, as it so looks in your CSV file, it turns out that you can have these funky names in table that you can have in base R. And one thing I've also noticed as well is that, and this is more of an issue in the past than it is now, is that sometimes data frames, when you read your data into data frame, it doesn't respect or necessarily look at the way in which your actual the input type of your data. So by input type I mean like whether or not your data is a a double or if it's an integer. Data frame just treats them both as numerical values, right? Which in the past had a series of implications because how you perform operations on decimal places versus integers was mattered. Now it doesn't matter as much because numerical, as on numeric in R kind of treats them as similar. You can do similar things on integers and decimal places, but in the past, the input type actually mattered as it pertained to how you perform operations across your variables. Again, now it doesn't matter as much because numerics in R, like as.numeric, as a function in R, if you just change your integers and your decimal places to numerical values, it performs similarly. But in the past, it mattered as to how you write in your input values. So if I actually was doing it, I was involved in the SSC competition this February, and so I was making a video, and I took the COVID data. I was playing around with it in Ontario at least. I was looking at like active cases as a function of your age. So those who were under 20, 20 to 29, 30 to 39, and etc. And I was looking at the active cases, resolved cases, and deaths, right, up to February 2021, because I wanted to use it to show something. You can see that when I read it into Tidyverse. So this is actually just to point out in the thing here, that's actually ages.csv. When I read it into Tidyverse, right, you can actually see that it looks like this. So notice that it actually reads in each input type as it is, right? So it recognizes, for instance, that active, resolved, and deaths are, doubles, resolving numerical values, things like categories, a string, etc. And that's what you're seeing in this table. So you can see this here, it recognizes a double here, it's a double, it's a double, it's a character. It's a character. So it's reading it in as a tibble. When you look at how it looks in base R, it actually just reads it in as a data frame. So it looks different. So if I, if I just have a look at, ages 2, you'll see that it just read it in as a data frame. It didn't really actually, that doesn't really mean, doesn't give you, it doesn't read it in as tibble. It's a data frame basically, right? So this is a bigger implication when you're working with different variables like integers versus doubles. It doesn't matter anymore now too much, merely because like the data set is very small for one thing, and two, we can obviously perform similar manipulations against integers and decimal places. But in the past, it did matter. But if this data set was very large, I might be inclined to use read_CSV just because it actually imports faster. And I've dealt with very, very slow. I've dealt with very, very, very slow data frames that have, when I use base R, it takes half an hour to load into my console, and I don't use it as a consequence. So that's where it really gets you. I do want to point out that you have to be a bit careful here, right? Because notice in the data set I actually gave you, they actually have working variable names, right? So if I pull up the data set, and this is something that's treated both base R and Tidyverse, you have to be a bit careful, right? You can see that they have variable labels, which is not trivial, right? Because if I remove those variable labels, this is what I created another data set called ages.csv, where all I've done is actually strip the data set of the variable labels. So it just looks like this, right? You will see that if you don't specify column names equals false, it will actually take your first row to be the column name, right? So if you have to be a bit careful here, right? So column underscore names equals false performs similarly to header equals false in, base R. But if I just remove this component, if I just run this, you can see that if I, if I preview this data set, you will take the first rows as a variable labels. We have to be a bit careful here, right? So if you don't have variable labels, make sure you keep this in mind. But this is something I actually messed up a lot when I first started working with. And then when I did the statistics, my numbers were off by a little bit because I was always removing the first observation, not knowing I was doing it. I mean, this has big implications, obviously, for data sets not very big. When you have very large data sets, I guess, like you can somehow miss this and not necessarily see it for a long time, because when your data set's large, things don't show itself, or anomalies don't show itself more than when your data set's small. But I was actually working with a data set of like 24 observations. 24 is even smaller than 32, which is the size of MT cars. So it was very small. And then when you remove your observation, you have the 23, and then the statistics was actually off by a lot, ironically, because it was so small. So if I run this with the recognition that I don't have, you see that it will just create labels for you. So this is something to obviously keep in mind. You'll see the same thing is true when you run base R. You will also take, funny enough, it will take the first variable label to be, like the header. So something to keep in mind. And like I said, this is probably to me not that interesting, really, because it's the way in which we read in data. But I thought I would point it out just because there's a lot to be said. If you have very funky data sets, like that has a lot of spaces, if you have a lot of white space, or if your spaces are not like typical, or you're right, you might see that you then really will play a lot with read R and the features. So if I just go to help, for CSV, you will actually see that if you have very strange data sets, like maybe you have spacing of like two empty like columns in your thing. So if I was that, maybe instead of having like just one space between them, you have like the next, you have like this is empty, and then you have another observation and this is empty, and you have one here. The way you have to be a bit careful to how you're reading your data, right? So in that case, when you have very funky or strange data, you'd actually notice you find yourself using this a lot. So then you can see that when you look at the actual read underscore CSV, there's a lot more things you can talk about. There's a lot of things like, column names, column types, there's even quotations. So this quotation trim equals true are things you would do when you have very funky CSV files, right? So we have very typical CSV file, but when your CSV file is very illogical, you find yourself using those things a lot more. Just thought I'd put that out there. Okay. I also find myself using tidyr and dplyr a lot. So in fact, dplyr more so than tidyr, just because dplyr is the way in which you manipulate your data, basically, right? And so we always transform our data. It's never the case when we get a data set that the data as it looks like is the endpoint. We always manipulate our data in some way. And it's important in some sense to have a tidy way to do this. Otherwise, your lines of code can be very clunky and ugly. So this is why I like dplyr a lot. So dplyr and ggplot2 are probably my two biggest packages I use a lot in Tidyverse, just because they're so efficient. But as tidyr implies, obviously, it's an efficient way to ensure that your data is tidy. I would say that probably the three biggest things you use is the pivot wider, pivot longer, and gather. And obviously, these are common things you use when you have like repeated measures in some sense, right? So when you're repeating a measurement on the same observation more than once, you may want to go from wide to long format and vice versa. So these, in some sense, undo each other. Gather, ironically, is that sometimes I like to use gather instead of pivot longer, because pivot longer can be very ugly to use. So going from long to wide is easy in Tidyverse, which we use pivot wider. Going from wide to long is not always nice using pivot longer. Sometimes when you have multiple columns that you want to pivot on, so this by multiple columns, I mean that when you have more than one variable you're repeating measurement on for each person, you may not want to use pivot longer. You may want to use gather instead. When you have more than two levels to your actual variables for your column variable, it's easier to use gather sometimes, right? So I actually use gather when I wanted to go back from long to wide, because I found pivot longer was challenging in this way. And the reason I was doing it was because for the ages, there was more than two categories of ages. So I found it was difficult to use pivot longer. I had to use gather instead. These are the three common ones you use when you want to go from wide to long. Just to recall the ages data set, I think I may have had it here. Just want to see if I found it. Let me see. Yeah, the ages data set looks like this. So you can see that in the display I have here, there are at least 3 different ages. It's under 20, 20, 29, 30, 39, but it all goes all the way to 90 plus, basically. There's a lot of different levels for your ages. So when I go from, wide to long, that's not, sorry, when I go from, like long to wide, that's not the problem. And in fact, as I'm displaying it right now, it kind of looks a bit like it's in long format, because you can see that for each person who's like under 20, I put the date for February and November, so 2029. I put the date for November and February. So in some sense, kind of like a long format where I have like active, resolved, and deaths for each of the 2 different dates, right? So I'm going to convert this to wide format, right? So when I do this, I have to give a couple of things. I have to specify where I'm taking the names from. So what is the actual, in some sense, key? The key in this case is the date, basically, or it's the category, basically, right? So it's the category of under 20 all the way to 90 to 99, right? So I'm going to pivot this to wider format. So that it's coming from the ages, basically. I want to take the active cases to the deaths, and I want to put it in wide format, which means that instead of having it presented like this, where I have like, for each, date, here's active, resolved, and deaths, it would look stretched out, basically. I don't know why anyone would do this. Generally, I think you go from wide to long, but just in case some people have this situation where they want to go the opposite, it looks like this. Now, if I run this, you can see that, first of all, to do a pipeline, I have to take the original data set, which is ages. The original data set is up here, right? I read it in using the readr package. Whenever you want to do a pipeline, I don't know how many of you are using Mac versus Windows. You can see I'm using Windows because I've shared my screen, but I will, if I want to use Windows, do something like, Control, let me see, Control Alt I, so that's not it. Control Alt, I think M, yeah. Control Shift M, sorry. So Control Shift M is the command for, it's for Windows. When you want to create a pipeline, you use Control Shift M. I think it might be Command, or it might be Control Command M or something for Mac. It's a bit different. The command is slightly different for Mac. I can't remember, but I can look afterwards and probably let one in the quant or someone else know what it was if anyone's using Mac. But whenever I want to make changes, you make changes from left to right, guys, right? So when you want to create ages in the wide format, you're starting from age. Whenever you want to make a new transformation, you just, Control Shift M, and now I'm gonna make the change across from left to right. So this means that the change I'm making is I'm pivoting wider, basically, right? Now, the only reason why I can use this pivot wider function is because within the actual tidyr is a collection of packages that includes, notice, that includes tidyr, basically. So I just want to see, you can see that it's there, right? So let me see, yeah, tidyr is there. So the only reason I can use pivot wider, which exists in the actual tidyr package, is because I've downloaded Tidyverse, basically, because of course, if I wanted to install tidyr by itself, I'd do the following. That wouldn't really make much sense, because once I've installed Tidyverse, I had tidyr, basically. So pivot wider, again, names from, category values from. I want to transition from long to wide, so I want to stretch it. Again, I don't know why anyone would do this. Usually you go from wide to long when you want to do repeat measures, because you want to put it into a rectangular format instead of the opposite. So usually you want to go to long format to make it rectangular, but I digress. If I view ages wide, you'll see that it looks ridiculous, obviously. Like I said, I don't know why anyone would do this, but in case they do, you can see that for each of the dates, which is November and February, you get the active case of those who are, under 20, active cases for 2029, active cases for 30, 39, etc., all the way to active cases for those who are in their 90s, and then the resolved cases, and then on the DAS. You can see that it stretches it in a very silly way, because like I said, I don't know what kind of statistics you can do like this. The only thing I can think of is if you want to actually filter, if you want to remove maybe if you want to remove the entire set of observations, maybe from February, you just do it like, maybe it gives you a way to remove February's observations, then you just filter. Maybe you do it to what, maybe you want to get rid of this potentially, or you want to get rid of November, maybe you want to remove one of those two things, and it gives you a way to cut out the entire row and just work with the actual one of the dates, but otherwise I don't see why you do that. But anyways, going backwards is not easy using pivot R. So once you've stretched it to wide format, I don't find it nice to use pivot longer. So instead I use gather, which is also in the Tidyr package. So gather is nice because it gives you a way to go backwards with more, when you have more than one column. So you can see you actually have more than one column here. So you have more than one level to your variable here, because essentially you can see that you have active cases, resolved cases, and deaths. So you actually stretched out the data frame a lot. But as a function of 3 different levels, right? So you look at the deaths, the active cases, and the resolved cases, which makes it a little untidy. But gather is nice because all I have to do is specify in some sense how I'd like to gather. So I took, again, I'm going to create age long from age wide. So whenever I want to append, it's like an SQL sequence. You have to go to from left to right. So again, Control-Shift-M creates this thing here. Then gather, when you say val, so the variable name is going to give it one variable label, one variable name that will take the active cases, the resolved cases, and deaths, and put it into one column. And then it will take the value for so when you look at the case notes here, you can see that you get these case counts for each of the active, resolved, and deaths, which is going to constitute the values. So it's going to give you 2 columns. It's going to give you the variable label for active, resolved, and deaths, and it'll give you the value for those things. And I put minus date because I didn't want it to. I wanted to keep in mind that I wanted it to not include date when it's stretching it back to long format, so that it would give me something that resembles original data frame. So let's see how this looks. So minus date says don't include date in your formatting, because if you include date, the long format looks different. Basically, you can play around with it yourself and see what happens if you remove minus date and see how your actual data frame looks. If you're very curious, it does actually change the feature. So if I look here, you can actually see that again, because I didn't include date in my actual formatting, it actually does the active cases for November, active cases for February, and for all the age groups. And it puts the value, which is the value of the count you saw, basically. It does the same thing with the resolved cases and then deaths. If I did not say minus date, I don't believe I would have gotten 2 different dates for the resolved and active case for each of the different groups. But you can check and see what it does. It might have actually collapsed them into one aggregation of dates. It may have actually just collapsed them. So you would have gotten the sum potentially of these 2 things instead of having them separate. So, but you can check and see, some of these 2 things right across. They may have collapsed them into one value instead of looking at them as 2. But you can check and see if my suspicions are correct. Right. So I suspected that it was going to actually collapse the counts for November and February into one category, and I didn't want that. So, okay. That's pretty much the main things you use in Tidyr. It's usually you use Tidyr when you want to go from long to wide format. I would say the most useful other than ggplot is really actually dplyr. Why? Why is it most useful? Because you do a ton of awesome manipulations, right? So, and in fact, I think the most useful thing is dplyr because you have I don't know if you guys have seen mutate, select, filter, summarize, and group by. These are the most common ones. Mutate is great because it allows you to add new variables that are functions of existing variables. So for instance, let's suppose you had a continuous variable that's called age, and you wanted to add a year to everyone's age. Maybe you want to call your variable age +1 or something, or new age. You could add that. You could use mutate to create a new variable called new age based on the previous age +1. Select allows you to pick variables. It allows you to create new data frames that only selects the variables from your original data frame you wanted to choose. So it selects across a column space. Right? This means that if you want to remove some variables from your actual data frame and create a smaller one based on less variables, you would use a select function. On the other hand, filter is selecting variables based on the row space. So this is something to keep in mind. Select and filter are not working the same way. You might think they are, but they're not. Select actually goes along the column space. This means that it's selecting variables. It's selecting variables. So you reduce your actual you reduce the dimensional in the column space. If you want to go from, like, let's say 5 to 2 variables, it doesn't filter across the rows, which are the observations themselves. Filter removes observations along the row space. So if you want to keep all your variables, but you want to subset based on a smaller number of observations, you use filter. If you want to actually keep all your observations but reduce the number of variables, you use select. So they're doing different things, right? Summarize allows you to do things like means, medians, quartile ranges. It allows you to summarize multiple values into one value. So maybe you want to look at the mean of a group. You want to look at the median. And then group by is another useful one, because maybe sometimes you have factors. So maybe your level has like factors. If you want to group by age, for instance, which I will show you guys an example, then of course, if you want to group by age, you will see that certain opposite, but if you want to perform, for instance, you want to look at the mean across different ages, you want to group by age before you actually perform an operation like summarize. So when you summarize a certain variable, summarize across different groups, you get a mean for age 1, a mean for age 2, and etc. So I find that those are pretty useful. So I made this graph based on my data. All right, so how does Ontario cases compare across ages at different time points? So I looked at the time points of 2020 versus 2021. This was actually for the SSC video that I made in February. So you can see here, there's more to be done for my graph. As you can see, I could do more to remove this overlap here, but this is an introduction anyways. And you can see the legend gives me the 2 different dates, and it gives me the case counts for November and February across age groups. You can see for the most part, it looks like the case counts are consistent across the groups between February and November, like the way in which the cases are actually occurring across the age groups. It seems like most of the cases are occurring in the under 40, right? And it's pretty consistent across the different, except here, which is kind of funny because it seems that the cases went up in the youth, right? Here in February, I don't know why that happens. It's potentially maybe they went to school or something, who knows? I hadn't really looked too deeply into what were the factors that could have influenced that. I was just curious about the trends in general. So how did I actually process this data? Let's see. I actually had to do a couple of things. First, I actually wanted to make sure, so R does this very funky thing where if you don't organize your actual variables according to chronological order, so under 20 is younger than people who are 20 to 29, who are younger than those who are 30 to 39, etc., it will go based on alphabetical order. So we'll see that under 20 is alphabet that's in the end, that U is towards the end of the alphabet, and we'll put under 20 towards the end here. So instead of putting them first, it will put them last, and it will put them back here. So R, it's a huge pet peeve of mine with R in general, and it's even true in Tidyverse. You have to factor it yourself and reorganize the levels. Otherwise, under 20 will end up back here, just based on alphabetical order, basically, right? Which is very silly. But this is why I actually reordered it. I did mutate. So this is me creating a new variable called category based on the original variable called category. Recall, if I view ages, you can see that this is the original category, right? Which is organized like this, but when I put it into the graph, if I don't reorganize it, it will put under 20 last in the graph itself. But anyways, I'm using because mutate actually creates new variables based on the previous ones. You can see that I've created a new variable called category, category based on the previous variable. It's called category. So all I'm doing is I'm telling it how I want it to organize, and I want it to put under 20 first, and then 20 to 29. And it's very logical in the sense that I'm going up to the maximum age, which is 90 to 99, and then unknown is another category on its own, right? But you can see that otherwise what it would do is it would put under 20 after or right before unknown, which is completely illogical because you can see that these two are both U's. It would put under 20 before unknown, and they will both be towards the end, right? This is me. This is what so again, remember I'm doing the sequence in from the left to right. So this is the first manipulation I've done is I've mutated this category. Then I don't know what unknown is. Unknown means you don't know the age of the people in the data, basically. So when I put filter, I'm not removing variables. I'm removing observations. I'm removing along the row space. I don't want these people here. I remove them. I don't want them in my data set. So you can see I'm going across the row space here. I put not, so this quotation is not equal to category, not category equals to unknown. So if I'm going to say this in English, I'm saying not the category equals to unknown, as in I don't want the category where people are unknown. So it actually removes those people. And then the next operation I'm doing, because then my pipeline goes to group by, is I'm grouping by date. That means that any other manipulation I perform is going to perform the manipulation for those in February and those in November. So this means that every manipulation from here on out is going to occur across 2 different dates, basically, right? So mutate. I want to create a new variable called total cases, which is obviously the sum of the active cases plus the resolved cases, because you guys know the resolved cases also include deaths, right? So technically speaking, it turns out that when somebody died, it's resolved. So actually, this here is a subset of this resolved case. So I don't need to add these two together because it's in resolved cases, right? So yeah, it's a subset of the actual resolved cases. So I've added those 2 variables and I've created something called total cases. So if I just run this up to here, you will see that if I view data frame, it will give me total cases, which is the sum of these 2 things, right? So every manipulation will create a new variable, right? To the right, because I'm doing that basically. Now, the next thing I'm going to do is I'm going to change my actual my thing into percentages basically. So you can see that I've changed I'm calling it percent cases. So I'm changing the actual total cases to percent cases, right? So I want to know how much of the total cases you see across. So when you add up all the cases across the ages, that's total cases basically. So I want to know how much of the total cases each age group has, right? So that means some of all the age groups cases is the total cases, but of course I can look at the total cases per group. And when I do that, I'm going against the right. And if I run this, you'll see that I'll get percentages for each of the actual age groups. So if I do data frame, I get this distribution here. We can see that a lot of the cases happen in the working force, just like maybe 20 years old to perhaps 50 to 59, whereas people who are retired and people who are very young, the distribution appears like it's getting lower across. So it's most of the cases are happening in the working force, right? Whereas it's sparse across people who are very young and very old. Then I can plot this. So then I'm using ggplot here. Again, I'm a big lover of ggplot. So these are probably my 2 favorite packages are dplyr and ggplot, right? So I'm going to plot a geom bar. So I'm making a geom bar. This is discrete. This is a discretization of my variable, basically. It's discrete. So I'm going to use geom bar, right? So you can see that I give it a data frame, which is called data frame. Then AES, if I just put category X and percent cases, what I get is a coordinate system that has nothing on it, right? So if I just look at P1 here, you just get a coordinate system because you haven't asked it to do anything, basically. Right. So if I add geom bar, and I've added a whole bunch of features, you can play around with it yourself to see what happens when I add and subtract features. But you can see here I put labels. So here, for once, I put labels here. That's why you see that like X is equal to Y in a title, basically. So when I run this, what do I get? I get this, right? So this is what it looks like before I play with the colors, basically. So this is initially, whenever you do a box plot, it always gives you blue and green, or sorry, it gives you pink and green, right? So this is, or a teal color, whatever. It gives you this, it gives you this. This is whenever you have, it's always gives this color here. I don't necessarily like this color very much. So I changed it myself using the, oh, someone has a question. Oh, goodbye, Eric. So I don't like this color, so I changed it using scale fill. And obviously you can see that I'm changing the legend, and the values are based on logically the dates, because there's 2 different dates, February and November. So I'm changing the actual values to blue and orange based on the dates. And that, like I said, whenever you want to change a feature in ggplot, you put plus. So I did, when I run this, I get this basically, right? So that's how I got there. Like a lot of manipulations that you can see actual sufficient in like Tidyverse. If I use base R, you will see that first I have to actually create the variable called category. So in base R, it looks like this. Create the variable called category, run it. And then to update, you have to do data.frame ages, which is your initial variable plus the category. So you can see that every time I want to update a variable in base R, I have to create the variable externally and then append it to the data frame, which is very clunky and ugly because if you have too many variables you want to create, when you want to go back and look at your code, this can become many infinite lines. So it looks clean in this case here because I've only waited one manipulation. But technically speaking, I would have to do all these manipulations after the fact, which is like the filter. You know, the new variables are created here, and etc. I'd have to create all these manipulations over here externally, and then add it to data frame, which looks clunky and messy. And when you want to go back and look at your code, it will not become obvious to you as to why you perform certain operations. So I like Tidyverse because it allows you to almost like an SQL sequence keep appending to your data in a logical way from like left to right, which is cleaner than creating lines and lines and lines of code where you create new variables and add it to your data frame. So this is why I don't use base R, because you can see that this is already kind of involved, which is what I showed you in base R, but it still looks a lot more logical than if I were to actually do all these manipulations externally and then put it into data.frame, where data.frame, just to be clear, is a base R function where you're creating a new data frame within base R, basically. So yeah, that's it. Thank you. I actually literally finished right at 2 o'clock, so that's great. I guess if anyone has any questions, that's great. Otherwise, you can find all the stuff I talked about like here. Yeah. Thanks for listening.
Thank you so much, Nnenna. I loved how you showed some of these features in base R and how that is different from Tidyverse. And yeah, I've moved to Tidyverse since it came out. But initially it was ggplot and dplyr that was lingering, and before they came out with the Tidy Universe.
Yeah, it's always the ones people use the most, to be honest. Yeah.
Wondering if anybody wants to ask a question to Nnenna.
Does anyone have any questions?
I actually have a question.
Mm-hmm.
In ggplot, I can never remember when to use scale fill manual or discrete fill manual.
I think scale fill manual you can use primarily when you have things that are, so discrete, you have to have a discrete variable. So if you put scale fill manual, you can use for continuous things as well. In fact, if I go back and I remove, for instance, if I remove the as dot factor CYL and I just put CYL, it will give me a gradient that's colored, that looks like it's continuous. It will give me a continuous gradient for this thing here. So if you just remove this thing here and put CYL as your thing,
right?
Sorry, not here. If you go over here and you put, instead of having as dot factor, just put CYL, because CYL is 4, 6, and 8, which is, you know, numerical values, it will give you a continuous gradient scale. If you don't put as dot factor, so it will always give you it will give you a continuous gradient scale as long as you put something that's numerical for you. So it works in continuous and discrete cases. With the other one, you surely only have discrete values. The reason why I was able to use this is because I put as dot factor, but if I remove this, I believe that what it will do is it will give me, I think it will give me something that looks like continuous.
Right. It'll look like a gradient of blues or something.
Yeah, it will just say continuous scale applied. It will say continuous values applied to a discrete. It will look like a gradient basically. If I remove these things, yeah. If I just put color and I remove like the scale, it will just say, it will give me it will look like a gradient.
Yeah, and you're using scale underscore color manual instead of discrete color manual, because it's still a numeric value.
Yeah, it's numeric. Yeah.
Okay, thank you.
Any other questions? ggplot's actually my favorite thing forever. It's easily the best thing that came out of Tidyverse. Like dplyr, I respect because anyone who does a lot of data analysis will realize the variables you work with first are never the ones you keep, but we always manipulate our variables somehow, just because we realize that some things we could remove or something we could add. But ggplot makes things look amazing, right? So in fact, when I was doing the thing for my master's in public health, I was using ggplot, and it gave me this awesome like poster that I created. Like you get like these ridiculous, awesome things in ggplot, which you just can't get from base art. It doesn't make it look as aesthetic. It's like phenomenal, I think, personally. But that's just me.
Yeah, I agree. There's so much. I mean, ggplot is a much more powerful tool.
Yeah,
and
for sure.
Yeah, I like how you can also easily change the colors, because the default color is nice, but sometimes you sort of get sometimes it feels overused, right?
Yeah, it's always pink and green. It's very overused.
Yeah.
So, and also red's my favorite color, so I always have to have it somewhere in my plot. So I was like, no, this is not good.
I have a quick question. I think that this might be a little bit complicated, because when you showed us how we can pivot the white data set back to the long version, and so the variable name, there was like one column, it was like active resolve and death. So it was like active 22.
After this one here?
Yes. I mean, the next line where we had, we were trying to go from white to long, back to long. So the second variable was a combination of two variables, which is the status, resolved, active,
and death. Actually, is a combination of three. You know, because you can see that after if you look at what it does. And what I think I could have confirmed or checked to see what happens. What would happen if I, for instance, don't put -8? I feel like it would probably aggregate them into two different. It would probably aggregate the value space, which I didn't want. But you can see that it actually gives you 3 different levels. So it gives you active, resolved, and deaths. Right. So it aggregates 3 of them. When I went to pivot, because of the fact that there's more than 2 levels to the thing, it's not just if it was active and resolved, I would have used long format. I would have used pivot longer. But the minute I realized I had 3 levels, it became a tedious task, and it kept giving me ugly formats that was not what I wanted. So I was forced to use gather, because I think it's a bit more robust when you have more than 2 levels. I've noticed personally. For me, pivot wider is never the issue. It's always pivot longer that I find myself struggling with a lot of times. Although I would say that gather can also be used to go from. I don't use it too much, but I don't use it too much to go from, let's say, long to wide, but you can use it. To be consistent, you could also go from wide to long and vice versa using gather, which is kind of funny because it almost makes it seem like pivot longer and wider are redundant. I don't know which came first. I don't know if pivot longer and pivot wider came before gather or vice versa. I haven't looked into it too much. It'd be funny if gather came after because you realize there's some issues with pivot longer, but I digress.
Yeah, like I wonder if is it possible to maybe also add a minus for the, I don't know, it might not work for active to death, because this is like a pivoting based on the data we
do something like the following, like minus death or something,
or minus something, so that we can get like a post pivoting value of variable just for age group instead of having, oh, I see, okay.
I think it does. So I think what it's doing is it's going active for each age group, resolve for each age group, death for each age group. So if I say minus death, I think probably what it would do is just give me active and resolved cases.
Right.
But I think the funny thing is that if I didn't want deaths, for instance, maybe when I was in the wide format or something, I may have created when I was doing pivot wider, I may have actually thought a bit about maybe potentially, well, actually, probably would have just filtered out the DAS before I even began doing it to long format. I wasn't sure if I didn't want to do that in my data set. It's kind of funny because this is still not quite the format it started out with. Like if you think about how the initial thing looked like, it looked like this, right? So you can see that it actually had it in this format. So I need to do one more transformation if I wanted to actually get it properly where it was, right? I'd probably need to actually do another wide format. And I need to gather and make it a little bit wide again in some way. But once more, I need to use gather to make it wide again to remove these because this is right now it's a long format. If I wanted to make it wide, I need to do one more, like go back once more or something. Make it look like I did before.
Okay, thank you, Nnenna. I don't think we'll have any more questions, but of course, they can approach you and
yeah. I don't know if I put my email there, but anyways, probably if there's any questions, you can always forward it to me and I'll have a look or something.
Absolutely.
I guess I'll stop sharing my screen. Sorry.
And we'll stop recording.